Alright, so somebody asked me about that little R thing that came up on my calculator and doesn't come up on yours. And so we're going to talk about that R thing today. That R and the R squared, well, the R in particular describes a word called correlation. So correlation describes how strong your linear model is. Oops, put the microphone down. So a strong correlation means that your scatter plot looks very much like a line. It's almost a perfect line. A weak correlation means your scatter plot is not very close to being a perfect line. So we saw an example in the homework where these points here were all around. Would be a very weak linear correlation. And but we saw in many of the homeworks a very strong correlation. Positive correlation is going to mean the scatter plot's going up, and negative correlation means the scatter plot's going down. Okay, so that little R value that comes up on your calculator will tell us strong or weak. So we'll set some guidelines. They're a little bit bogus, but we'll set some guidelines for correlation. We'll say if my correlation R is greater than 0.6, we'll call that a strong correlation. Why is it blinking? It just does that. Okay. If my R is between, let's say, 0.3 and 0.6, we'll call this a moderate correlation. And if my R is less than 0.3, we'll call this a weak correlation. And because my correlation could either be negative or positive, my R number can be less than 0 too. So same applies for the negative R's, and those an R value that is going to be less than negative 0.6, or the absolute value of it greater than positive 0.6, is going to be a strong correlation. The correlation numbers go between -1 and +1. If you have a correlation of 1, you're on an exact perfect straight line. If you have a correlation of -1, then you're on an exact perfect straight line going in the negative direction rather than the positive direction. So we can kind of use these numbers when we go to describe correlation. So let's try. Expert visited a gallery and jotted down her guesses for the selling price for 5 different paintings. Then she checked the actual prices. The data points guess, actual show the results where each number is in thousands of dollars. First, we'll make a scatter plot and decide whether whether a linear model is reasonable. And then we'll make the line of best fit, so a little bit of review from yesterday. So we're going to put those points, we'll put the 12, 7, 10, 5, and 9 in list 1, and the 11, 8.5, 12, 3.8, 10 in list 2. So go ahead and do that in your calculator, because you're going to have to press one more button today in your calculator. Yes. So we'd like to, in real life, when we have equations, they're not exact. They're not going to fit every single real life point exactly. That we'd like a model that's close to real life. So, in real life, I go out and I get some data, and I look at the data. And I plot the data. Does this relationship look linear? Well, then I'd like to know the equation that kind of is pretty good at guessing what the relationship is. Well, we can have relationships that are not linear, and we saw that in the homework. This relationship is polynomial. So we'd have to decide whether or not it it is a polynomial relationship and how strong it is to a particular polynomial. When I go to make a mathematical model, I want my model to make some to be pretty accurate for what my real life data looks like. So I decide whether it's whether my data fits a strong linear model. Then I know my model's going to be pretty good. If if my correlation is weak, my linear model is not going to be very good. It's not going to be very helpful to me. The math isn't going to help me much in describing the real life situation. Okay, that's why we do it. Okay, in this situation where she's doing her guesses versus the actual price of the painting, who cares? But in science or on the Bay Bridge, you might care whether your model's good or not. Okay. Okay. Can I go on to the next button presses here? You want to go over the first button presses again? Okay. Then you're going to have to read off to me because I already have my buttons in here. The first button presses are stat, edit, number 1, clear out your old lists, arrow up to the top of your list until the L2 or the L1 is lit. Then hit the clear button and enter. Arrow over, arrow up to the way top of your list, hit the clear button and enter. Now since I don't have my page up, can you tell me what the values are I should put in list 1? Read them off to me. 7. Thank you. All right, in the next list. Okay, we're going to see how well she guessed. First thing I can do is make a scatter plot. I can do the scatter plot on paper, or I can do the scatter plot on my calculator. Let me go through how to get the scatter plot on your calculator. You hit second, y equals. Okay, we'll go into plot number 1. I'm going to turn on plot number 1. The buttons that need to be lit after you've hit number 1, the on needs to be lit. You need to arrow down to the on button and press enter over it. Make sure the on button is highlighted, is what it's called. Then push the arrow down button and the very first graph needs to be highlighted. That's the scatter plot. Hit enter so that one is highlighted. If they don't already say it, your X list will need to be list 1 and your Y list will need to be list 2. In order to get list 1, you're going to need to hit second and 1. If a Y comes up, then you need to hit the alpha button to turn off the alpha button, I think. Yeah, that's usually what you'd have to do. And the Y list, second and a 2. And you can just decide how you want your graph to turn out on your graphing calculator. Do you want little squares, little pluses, little dots? Okay. We there so far? Okay. Now we're going to graph. But if I just hit graph, I have not scaled my XY axes for this new problem. I'm going to let the calculator scale my XY axes for me. And that's called zoom. And it's number 9. It's called zoom stat. So there's number, you can arrow down to number 9 or you can just hit the number 9. Okay. Do you think we have a strong linear model?